Welcome back to The Explainer. Okay, today we're doing something a little different. We're going to look past the stars and straight into the darkness, because we're on the hunt for this invisible architecture, a kind of hidden skeleton that holds our entire galaxy together, and maybe, just maybe, holds the secret to us too.
You know, when you look up at the night sky, what do you see? Right, the stars, these brilliant little pinpricks of light. But what if I told you that's not the real story? That the most important thing happening up there has nothing to do with the light. It's all happening in that vast, black, seemingly empty space between them.
So check this out. On the left, yeah, that's the sky we all know. But on the right, that's the universe astronomers are just now starting to see. It's a place where all that empty space is actually buzzing, woven together with this huge invisible network. The darkness, it turns out, is where all the action is.
Okay, so that leads to the big question, right? If there's this secret structure hiding out there in the dark, how on earth do we see it? Well, the clue, the key to the whole mystery, is smaller than you could possibly imagine.
Get this, our hero in this story is interstellar dust. And no, I'm not talking about the dust bunnies under your bed. I'm talking about trillions of tiny needle-shaped grains just floating around in space. These little specks, they're the key. They are how we're going to map the invisible forces that shape everything.
Okay, so to get how this works, we got to look at what one of these little guys is made of. First, the shape. Super important. It's not a round ball. It's long and thin, kind of like a needle. Then it's got this protective layer like armor, made of water and ammonia ice. And deep inside, a tiny little core of iron. And believe me, every single one of those parts is absolutely crucial.
All right, let's dive into how these simple little dust grains turn into basically high-tech galactic compasses. This is where the physics gets, well, it gets really cool. Okay, so here's the four-step process. Step 1, starlight hits the grain, and boom, it starts spinning like a tiny windmill. Step 2, that icy armor is key. It lets off heat so the grain doesn't just explode. Whew. Step 3, as it's spinning, that little iron core acts like a gyroscope, and it literally snaps the whole grain into alignment with the galaxy's magnetic field. And finally, step 4, when you get trillions of these things doing it all at once, they become this giant cosmic filter for light.
And when I say they spin, I mean they really spin. We're talking up to 10 million RPM. 10 million! That's just mind-boggling. It's a blur of pure energy, and the only thing stopping it from flying apart is that thin little layer of ice. It's this incredible, tiny balancing act happening all over the galaxy.
But, okay, here's where it gets a little weird. There's a paradox. We call them dust clouds, right? That word is completely wrong. These clouds are actually some of the emptiest places in the entire universe.
So why do they look like clouds? It's just a trick of perspective. It's exactly like a really, really thin fog. It only looks thick and soupy because you're looking through, miles and miles of it. But in reality, these individual dust grains could be kilometers or even light years apart from each other. That's just nuts.
And that's the whole point. That isolation, that emptiness, is exactly what makes this whole thing work. Each little grain is its own perfect, tiny laboratory. It's totally free to spin up and snap into alignment without ever bumping into anything else. So the emptiness isn't a bug, it's the feature.
So the big question is, how does this all add up? Right? How do trillions of these tiny, independent spinning needles, scattered light years apart, create something that we can actually see, something we can map?
Well, just try to picture this. Across thousands of light years of what looks like totally empty space, you've got trillions and trillions of these little microscopic compasses.
And every single one of them is spinning at these insane speeds, all of them snapped into perfect alignment by a force we can't even see, all pointing in the exact same direction, tracing these invisible lines. And together, they create a map. They're not making any light themselves, but they change the light that passes through them. And by doing that, they give us the blueprint of the galaxy's hidden skeleton. So here's how we read the map. When starlight travels through all this aligned dust, it gets what we call polarized. The picket fence analogy is perfect. The light is forced to wiggle in only one direction. So here on Earth, all astronomers have to do is measure the angle of that polarized light. And by doing that, they can trace those magnetic field lines all the way across the galaxy.
We are literally using the unseen to map the invisible. How cool is that?
But this map, it shows us so much more than just physics. Because this whole process, happening out in the coldest, darkest corners of space, well, it might just be the reason you and I are even here to talk about it.
And this is where a guy named Mayo Greenberg, an astrochemist, comes in. His work was just visionary. He looked at all this and didn't just see a cool physics trick. No, he saw a factory, a cosmic cradle for the building blocks of life itself.
So Greenberg's big idea, which has now pretty much been confirmed by missions like Rosetta, is that these icy dust grains aren't just spinning, they're cooking. They're little chemical factories building complex organic molecules. And get this, that polarized starlight we talked about? It gives those molecules a specific handedness, the exact same left-handed shape that's in our DNA. Mind blown. And then these ready-made ingredients for life got delivered to a young Earth by comets.
So you see, this changes, well, it changes everything. It means we've been looking at the universe all wrong. We were so focused on the shiny objects, the stars, that we just assumed the dark spaces in between were empty, boring nothingness. But the real story, the story of where we came from, it happens in the dark. So this is the new picture of our universe. That quiet black void isn't a void at all. It's a bustling cosmic factory. It's forging the raw materials for planets, for stars, and yeah, for us. The dust in the dark is the secret ingredient to everything we see in the light.
So, next time you're outside on a clear night, do me a favor. Don't just look at the stars. Look at the vast darkness that's holding them all together. And ask yourself, are you looking at emptiness, or are you looking at the cradle that made us all? Are you looking at home?